By the end of this video, you should be able to graph an absolute value function in the form that you see here. And I'm going to refer to this as vertex form, but this is kind of like standard form of an absolute value. And we're really concentrating on A, B, and C here. Remember, a function is just an input, and then you get the output. So A is going to refer to, I don't know how you want to think about it. It's kind of like the slope of the lines that form an absolute value function, or the steepness is another way to think about it, because an absolute value function is not a straight line. The B value, so the number inside of the absolute value, is going to be the horizontal shift, moving it back and forth along the x-axis, and the C value is going to be the vertical shift, moving it up or down. And so this is an introduction to vertex form, and we're going to come back to this occasionally with different functions. And the nice thing about this is a absolute value function is a pretty easy thing to start with, and we're just going to, it keeps basically the same shape, and we're just going to move it around and change a couple things. So I want to go through step by step what each of the values A, B, and C do to the absolute value function, and then at the end we're going to put it all together. So we're just going to start with just the real basic one, the absolute value here of just x. And I guess if you want to really know, A here would be 1, B would be 0, and C equals 0. And you can play along on your graphing calculator if you'd like to test all these out. And so this is the basic shape, and there's a couple things that we need to recognize here first. This right here is the vertex. And when you have just the basic absolute value function here, notice that the vertex is at 0, 0. And the other thing I want you to kind of see is that, when there's no number out in front, that means it's a 1. And I want you to notice what the slope is doing here, or at least of the slope of this line. So it's going up 1, over 1, up 1, over 1, up 1, over 1, right, in a positive fashion. But then we have this going on also. So this is really a reflection. And so that's why, you don't really call this slope, but it's kind of doing the same thing as what the slope does. And that's why the absolute value is a nice, easy one to start with. So this is the general shape. Now, why is this the shape? So if you really are up on your functions, it will make sense. We're going to pick a couple points, and hopefully you'll understand that this shape makes sense for an absolute value. So remember, a function is an input and an output. So what happens when we choose some of the positive values of x? Right, as we go along, what happens when we plug 1, 2, 3, 4 in? Well, f of 1 would be the absolute value of 1, which is 1. Oops. F of 2 would be the absolute value of 2, which is 2, and so on. But what happens when we choose negative inputs? So for instance, when we pick the -1 for the x value, well, the absolute value of -1, right, absolute values make it positive, so it comes out to be 1. So instead of, like a linear function where it would continue the pattern, the original pattern, right, when the input is a negative, it will output a positive. And so that's why we have this basic shape. So let's mess around with the value of A first and see what it does by plugging in numbers to our the shape of our graph. So, again, in function, we're just going to plug in some easy ones. I have the black one here is the regular f of x equals the absolute value of x. So when a becomes a bigger number, let's see what happens. So, again, if we plug in 1, we're going to get the 2 times the absolute value of 1, which is 2 times 1, which is 2. And so when our input is 1, our output now is going to be 2. So if we continue on this pattern, let's pick when the when the input is 2. When we plug that in, we get 2 times 2, which is 4. So when the input was 2, now we get 4. And so this pattern is going to continue. And, at the beginning I referred to this as kind of like slope. So if you think about a as slope here, would be a slope of up 2 over 1. And so we go up 1, 2 over 1. Right? 1, 2 over 1. And so that pattern is going to continue. And so now we've increased the steepness. So we start inputting negative numbers, something similar is very similar is going to happen. So, right, if we plug in -1, we're going to take the absolute value of -1 and get 1. And 2 times 1 would be 2. So when the input was -1, the output was positive 2. When the input is -2, right, the output will be 4. And so again, it's just a reflection. And so as A increases, this steepness will get steeper and steeper. The slope will get steeper and steeper. So let's see what happens when A becomes a fraction. So I'm just going to plug in some even numbers just so it works out nice and pretty for us. When the input is 2, right, we plug it in, the absolute value of 2 is 2, so then we really get 1/2 times 2, which is 1. So when the input is 2, the output is 1. So we move on to 4, again, just because it's nice and pretty. So when you plug in 4 into our function, right, absolute value of 4 is 4, 1/2 times 4 is 2, and so then we get this. And this pattern, again, will continue on. So now we'll enter the negative inputs. Again, the absolute value causes it to become positive. So 1/2 times 2 is 1. So when the input is -2, the output is 1. When the input is -4, right, it makes it positive. So then our output would be positive 2. Okay, and again, that pattern is going to continue. So now let's take a look at what happens when A is negative. So, if we plug in 1, the absolute value of positive 1 is 1, but since the negative is on the outside of the absolute value, the output becomes negative. So we plug in 1, and now the output is negative. Okay, and so as we plug in more negative or more positive values, the absolute value becomes positive, and the negative on the outside makes the output negative now. Okay, and so then when we want to plug in a negative number, right? The absolute value forces it to become positive, but the negative on the outside remains. And so then all that's happening is that it's reflecting over the x-axis, right? There's no way we can get any positive answers. So because of all that, we can say a couple general things about what A is doing. And don't get mixed up just because, I'm using these inequalities, right? So all this is saying is when A is a positive number, the shape of the absolute value function looks like a V. When A is negative, it's upside down. And that's just what we showed in the last couple slides. When A is 1 and above, right, the V shape becomes more narrow. And again, you can just count it like it's a slope up and over. When it's a negative integer, basically, the V shape is upside down because it's negative, but it continues to become narrower. When A is somewhere between 0 and 1, so think of a fraction, the V shape is wider. And when it's a negative fraction, below 1, or in between negative 1 and 0, the V shape is upside down and wider. So let's move on to talking about B. And so I have two functions. Again, I get the original f of x equals the absolute value of x. And so we're going to see how B moves around. Now, you may be looking at these and saying, well, it looks like x is, or, the B value here is negative 2, but I'm writing down positive 2. And then you might be saying, well, it says that it's x plus 3, but I'm writing down that B is negative 3. And that's just because the original formula, the generic formula of the absolute value looked like this. And so that negative sign was already, or that subtraction sign was already there in the function itself. So if that's the case, then in this one, B must be positive 2 because the negative sign isn't changing. But since the sign changed from negative to positive, that must mean that B is negative 3. And so that's all the reason for that. So I'm going to pick 3 values and plug it into G. Of course I wrote F. Okay, that's better. So I'm going to plug in a couple values of G to see what happens. So this is going to be the absolute value of 0 minus 2, which is the absolute value of negative 2, which gives us 2. So when the input was 0, the output was 2. So now we have a point there. When I plug in positive 2, we get 2 minus 2, the absolute value of 2 minus 2, and we would get the absolute value of 0. So when the input was 2, the output was 0. And I'm going to change this one up. Let's do, instead, let's do 4 here. So when we plug in 4, the absolute value of 4 minus 2 is the absolute value of 2, which is 2. Which is 2. So then when it was 4, the absolute value is 2. And so notice that the slope doesn't change. It's just the vertex changes. So all we did was shift it to the right 2. Okay, so we're going to make a general statement about that, but I do want you to notice that when the formula says minus 2, we moved it to the right 2. Okay, so let's move on to the h function, and I got 3 numbers that we're going to put in and see what happens. So when the input is 0, it's absolute value of 0 plus 3, which is the absolute value of 3, which is 3. So when the input was 0, the output was 3. Let's move on to negative 3 and negative 6, sorry. So then when the absolute value of negative 3 is in, negative 3 plus 3 is the absolute value of 0, so that's 0. So then when the input is negative 3, the output was 0. And move on to negative 6. Absolute value of negative 6 plus 3 equals the absolute value of negative 3, which is 3 again. Okay, so again, notice that basically all we did was shift it to the left 3. It does say x plus 3, shifted to the left 3. X minus 2, shifted to the right 2. Everything else stays the same. The slopes or the angles are still parallel there, or the lines are still parallel. So then we can say a couple generalities about the value of b. And so I don't want to confuse you about when it's positive or negative. So let's just say that if you have an x minus inside the absolute value, it goes to the right. If you have an x plus inside the absolute value, it'll go to the left. So let's move on to the final part here, c. And what I will say is that for the g function, c is going to be 2. And for the h function, c is going to be negative 3. So it's not as confusing as when it's inside the absolute value. But let's see what happens when we plug in a couple values here. So for the g function, when our input is 0, we'd have the absolute value of 0 plus 2. So our output would be 2. When the input is positive 2, the absolute value of 2 plus 2 would be 4. And when we put in the absolute value of negative 2, we would again get 4. So again, the shape stays the same. We just shifted up 2. Positive 2. Up 2. So now on to the h function. Picking the same numbers here. Yeah, the absolute value of 0 is negative 3. So then when x is 0, y is negative 3. When we plug in 2, the absolute value of 2 minus 3 would be negative 1. And when we do the absolute value of negative 2 minus 3, again we get negative 1. Notice that it's the same shape, right? Just shifted down 3, right? Negative 3, shifted down 3. Positive 2, shifted up 2. So here's what we can say about c then. If you have the form of the absolute value plus c, it'll shift up. And when it's the absolute value of minus c, then it'll shift down. So everything is compared to the original one, f of x equals the absolute value of x. So this is going to be the last time I draw it on there. But let's just see, I'm going to do a couple example problems of the whole thing in action. So, right, a here is 1, so it's going to be the same slope going on as the black function here. But our horizontal shift is to the left 2. Our vertical shift is up 4. So I'm just going to start on the vertex and let's find that. So if the original vertex is here at 0, 0, we want to go to the left 2 and up 4. And since a is 1, it's just going to still be on this diagonal. So here's one more without messing with a at all. So the vertex goes from 0, 0, and since this says minus 5, we're going in the opposite direction, so we're going to come over here and start at positive 5, but then again up 2. So then our vertex is right here. A hasn't changed, so it's still up 1 over 1. So not only on this one is the vertex shifting a little bit, but I also have a different slope. So, I'm going to start with where the vertex is. And since it says x plus 5, that means we're going to the left 5 and then down 1. So then our vertex is right here. And now instead of just on the up 1 over 1, we're going to go up 1 over, right? Up 1 over 1, 2, 3. up 1 over 1, 2, 3. I can't draw it. Shoot. Okay, so again, I'm going to start with the vertex. X minus 1 means it goes to the right 1, and then up 2, so that's where our vertex is. We have a negative a now, so it's going to be flipped upside down and have a fairly steep slope. So we're going to go down 2 over 1. Right? Down 2 over 1. And it's going to go in the same order, or same pattern, on the other side. Okay, so that's really all there is to it. Just remember that it's opposite direction on the inside, same direction on the outside. If it's a negative, it's going to be in this shape. If it's a positive, it's going to be the normal V. And then you're just counting up and over like you always did with a slope.